Okay, hi, I'm Noelle L'Etoile, and I'm a scientist. Uh, I study cell ligands at UCSF, and I'm here with Ruben Castro Corral, who's going to interview me.
Thank you, Noel. So my first question to you is, during childhood, what were your career aspirations?
Well, the earliest I can remember, I was 4, and I wanted to be a fairy princess. After that, I decided, oh, fairy princess, maybe doctor. And then I was like, oh, very cool. I could deliver babies because, what could be cooler than that? And as I decided babies weren't so great, I got a little older and I decided I wanted to be a vet. And that actually stuck with me for a long time. I really wanted to be a vet. And I read books uh, that by James Herriot, and it's a PBS or BBC actually production right now. It's All Creatures Great and Small, and he was also a writer, and so I want to be a writer too. I want to be a vet and writer just like him, and then I actually went to college, and vet school is really hard to get into in the US. So I was like, okay, back to med school. And so then I wanted to be a doctor all the way through undergrad, and I took like pre-med classes, and I had to work my way through college too. So I was a dishwasher in a lab because they said that would be good for med school. And dishwashing was boring, and I broke a lot of dishes because back in the day we had like glass petri dishes. Anyway, and so I like people said, oh, she seems smart. I don't know why they said that, but anyway, I said, oh, she seems smart. She should do some like research. And like all these different people were like, oh, yes, she can do research for me. And I was like, okay, I'll do that. And it was so exciting, so fun. I got to ask these like really great questions and design my own things. And I got hooked. And then I applied to med school, I applied to grad school, and I got into a medical school that was so expensive I would have to join the army to go to it. And I was like, do we really want to do that? Do that? And then I got into grad school and I was like, well, okay, it's a no-brainer. I want to go to grad school. So anyway, that was a long-winded way from my childhood to say that, yeah, I fell into being a scientist.
Oh, that's awesome. Thank you. Um, so what drew you to specifically working with C. elegans and working in neuroscience?
Yeah, so way back when, as I told you, I wanted to be a writer. And I wanted to be a writer because I like the interior of our minds. And I'm really interested in like our interior landscape. And so schizophrenia was always really interesting to me because like, wow, those worlds are like cool, you know. So I wanted to understand schizophrenia kind of like as a writer, but also as a scientist. And so I was always really fascinated by neuroscience. But I was a biochemist in, in college, and I really liked molecules, and I liked like the precision of clean understanding. Like I could ask a question and get an answer. And so I was like, how in the world can you do that with neuroscience? So in grad school, I did something that I kind of, in retrospect, I would not suggest people do, but maybe it was okay. I went into biochemistry in grad school, and so I did hardcore like molecules interacting with other molecules, and I learned biochemistry really, really well. But it was a little bit soul-sucking. And so I decided as a postdoc to go and do something that would be a little closer and study human diseases. And I studied them. I started to try to study them in worms. And when I looked at C. elegans, I was like, wow, they do things and they do cool things. And I don't have to kill things that have a vertebra. So because I'd done a lot of mouse and rat research as an undergrad, because they say that's good for you in med school. And then in grad school, I had to do a little bit. And like I just couldn't stand killing any more animals. But I love to ask questions about the behavior. So and I think that like it brings together two of the really important things to me is like to be able to ask really deep questions that you can dive into the molecular cellular answers, but also like get at like, oh, what are these little creatures thinking? Anyway.
Uh, Thank you. That was a really good answer. Um, what would you have to say that has been a rewarding aspect of your scientific work and your pursuit as a scientist?
Yeah. One of the things that is the most rewarding that I didn't act well, okay, so there are several things that are really rewarding. One rewarding thing that I really did not understand that I would like so much is being a mentor. And I really like to see people grow, and I really like it when people make their own discoveries. And when like people go out to try to find something, like I tell them, hey, for example, Nando, we really want to understand transgenerational inheritance. And he's like, okay, I'll try that. And instead, he found that worms sleep. And then Laura, she's like, she just went on her own and found these spiraling worms. And then Ruben, who's in front of me here, like, hey, let's look at some worms sleeping. Oh, let's look at older worms. And he's like, whoa, I found this weird thing, Noelle. Anyway, we'll talk more about that later. And who knows what that will be. But everyone comes that spends a lot of time with what they do and deeply thinks about what they do, has a little like, ah, and that's the other thing about science that I love is like that you don't predict it. It's like falling in love or something. You don't really know. You can't, you're like, blah, 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 blah. This is the perfect person. And then you meet them, you're like, ugh, gross. But it could be that like there's somebody like who knows where, and they're like, oh, there's some spark. And that's the way I think like good science is. It's just magic. It's kind of like you don't expect it. You kind of just keep your eyes open and your mind open, and it's like a spark or something.
Thank you. Um, would you describe your career path as linear, or did you experience any adversity or any type of setbacks to get to
Yeah.
where you are today?
Yeah, it was super linear now that I think about it. I in the past I would have said no, it's not linear, but it was like I feel like it was kind of like like I just told you, kind of very straight from undergrad to grad to postdoc to a professorship at UC Davis is where I was the first a professor. And so yeah, it was it was pretty darn linear. Um, the adversity was there were several parts of adversity. Like as an undergrad, I really struggled. And I just hit my head against a wall trying to do something very simple. And then someone taught me how to do it. And it was like opening up my eyes. It was like, oh, wow. And then anyway, so I got over that roadblock. That was one adversity. And then in grad school, none of my experiments worked for 3 years. And then I started studying for my MCATs with all seriousness again to go to med school in the middle of grad school. And that was a big, big setback. And I was working on a project that was intractable. And so sometimes, like and then I saw another project in lab that was like somebody decided to leave lab early. It was a project that had a lot of preliminary data. And I just knew I had to do step one, two, three, and then I would get the publication and graduate. So I did that. And then once I got the publication, I was like, oh, this is so much fun. And I just want to keep going with it. So adversity like can make you like hurt, but if you keep going and you never give up when you're down, I think that's the key for what I learned is like, had I given up when I was down, I think I wouldn't be as satisfied as like if I tried to get up to like my success point of publishing that paper and getting my PhD. If I decided to change my path, then I would be up and changing my path rather than down and changing my path. So I think one should always make one's choices when one is like up and then have a success in what you think you want to do, and then decide if that's really what you want to do or not. And so, yeah, and then my next set of adversity was actually getting my job and having kids. I love kids. I love my kids. They're not the adversity. The adversity was like I was driving 160 miles a day, had three small kids, and I did this for 10 years, and it was so hard, so hard. Yeah. And in some ways, it was my kids are a total blessing. But it meant that I had to like reach out to my family and have them help me raise my kids. And that was super like humiliating to do, to say, hey, I can't do this on my own. But like most good things, it's like such a blessing. So my kids know my parents well. It's an intergenerational family. I got to be around my parents a lot, which is really special. And yeah, so that was my biggest adversity was Davis was also in many ways like one of the biggest blessings too.
Thank you. About my last question for you is just what advice would you offer to students or early career researchers?
Oh, I've given you a few pieces of advice as we've gone. Yeah, don't make a decision to ditch something you think you might like when you're down. Try to get some success and do that. And sometimes the success is not by doing the same narrow thing over and over again, like that biochemistry. Like try something else within the realm of what you think, and then see if you have success or some sort of like happiness. Yeah, don't get stuck trying to do something like that 3-year project. Maybe like figure out that something isn't going to work too, a little sooner, and then move on, kind of like Nando with this. I just mentioned briefly this one thing he was trying to find, and then he found something else brilliant. Or Laura, when she started, she was trying to find something hard and different, and she found this brilliant. So, don't be too stuck in science. Move around. Um, and also the type of science. Like if you think you really want to do science, then maybe genetics are not for you, and so try microscopy or something, or just try the different techniques, because techniques can also be the thing that like gets you down or gets you jazzed up about it. Let's see what else about for beginning scientists. Yeah. Um, Find good mentors. You don't have to be in a lab with someone mean. Like there's so many really good scientists that are also good people. So talk to people who have been in other people's labs, because I think that's really important that you're with people who will support you, because that's another reason that one might run away from science. And throughout my whole career, I've always like looked for mentors that people say are good, because I don't want to waste my time with people who are not good, like that are mean.
Oh
Yeah.
yeah, definitely.
Other thing is science can be lonely, so make a community. Like I like some of the best things, some of the funnest times in my life were like in labs where people were like kind of, and I don't know what the magic is or what the recipe is, but when they were all kind of like in the same like cohort of time of doing things. Like there were a few graduate students and me, we were like really close. And like some of my best friends were like from labs at those times. So I think like building a community in science is kind of important. And you can bolster each other up with like asking each other scientific questions, but also just life and having like places to go to visit different cities and stuff eventually, wherever they wind up, and just networks of people that you get to know scientifically too. So I think that's important, building community. Is that it?
Yeah,
All
that's it for
right.
my question. So thank you very much for your time.
And what is this for exactly? What do I do? Do I just click the Zoom?
Oh yeah, we can just end it. That should be
I